Hello guys and welcome back. Today we are looking at the third question of the third theory of computation internal, which is based on automata theory. Let us look at the question. Construct a Turing machine that accepts the set L of all the strings over 0, 1 ending with 0, 1, 0. Now, as we know, a Turing machine is a 7-tuple. One of the main disadvantages of push-down automata is that it does not have a proper way to read the input string. To counter this, we have a Turing machine that reads the input from a magnetic tape. Hence, the blank symbol in the Turing machine formula is used to represent the blank symbol on the magnetic tape. The symbols in Q indicate Q, which is a finite set of states, sigma, which is a finite state of alphabets, which as given in the question is 0 and 1, delta, which is the state transition function, gamma, Q0, which indicates the initial state, blank, which indicates blank on the magnetic tape, and F, which indicates the final string. Now, we have a Turing machine diagram that has four states, Q0, Q1, Q2 and Q3. As we know, Q0 accepts 0 as well as 1 and moves on to right on the magnetic tape. As we can see in the state transition table, when we are at Q0 and we have 0, we accept 0 and stay at Q0 and move on to the right on the magnetic tape, or we accept 0, move on to Q1 and move right on the magnetic tape. When we have 1 at Q0, we stay at Q0 and we move on to the right on the magnetic tape. At Q1, it does not accept 0, therefore it can go to the reject state. At 1, we can go to Q2 and move right on the magnetic tape. When we are at Q2, it accepts 0 and moves on to the right on the magnetic tape and goes to the symbol Q3, which is the final state, and hence Q3 does not accept anything. This Turing machine accepts all the strings that end with 0, 1, 0, which consists of the alphabet 0 and 1. Let us look at the code for this question. We have a class Turing machine that defines three states, Q0, Q1 and QReject. Now we have the input alphabets 0 and 1 and another string that is toString. Now for the tape symbol we have head is 0, that is we are used to defining the head of the magnetic tape. We have the current state which is 0, which is the initial state. Now while the tape of the head is true, we indicate that if we are at Q0, it gives the tape head accepts 0 and we increment the tape head and stay at Q0, or we move on to Q1, or we move on to the reject state if it is an invalid state. Similarly, if we have 1, the tape head says 1, the head is incremented and we move on to the current state. We can see in the main function that it has three strings, 0, 1, 0, which is accepted by the Turing machine, 0, 0, 1, 0, 1, 0, which is also accepted by the Turing machine, and finally 1, 1, 1, 0, 1, 0, which is also accepted by the Turing machine. Thank you for watching. Please like and subscribe.